Here we want to talk about the different formulas applicable for different scenarios. Let's consider compound interest compounded yearly. Here the time period is 1 year. So it's a very simple case. Amount is P, which is the principal, multiplied by 1 plus R over 100 the whole power 1. So this technically lets the principal grow for a period of 1 year at this given rate of interest. If it was 1.5 year, my time period was n is 1 over 2 years. If that is the case, now here we know that the compound interest is supposed to be compounded yearly. So this piece gives us the growth on the principal P for a period of 1 year. Since we have to compute for another half the year, so we are multiplying this component with 1 plus R over 2 times 100 the whole power 1. So R over 2, if the rate of interest is 10% for the whole year, so half the year it is supposed to be 10 over 2, which becomes 5. So this precisely halves the rate of interest. And here we know for in 1.5 years there's one period of 6 months. So my formula has become P1 plus R over 100 the whole power 1 times 1 plus R over 200 the whole power 1. If it is 2 years, then the exponent raises to power 2. If it is 3 years, the exponent raises to the power 3. If it is 2.5 years, the exponent is raised to the power 2, and this gives you for the rest half the period, half the year. Similarly, if it is compounded half yearly, my amount is going to be P 1 plus R over 2 times 100 the whole power 2. How do we derive this? It's very simple. R over 2 halves the rate. So if it is 1 year, time period is 1 year, which is corresponding to this. So we know in 1 year there will be 2 periods of 6 months. In a similar case, if it is 1.5 years, so we know there will be 3 periods of 6 months in 1.5 year. If it is 4 years, there are 4 periods of 6 months in 2 years. In a similar case, if it is 2.5 years, there are 5 periods of 6 months. Same for 3 years, it is going to be 6 periods of 6 months in 3 years. Now we should be happy that in our syllabus we will not get raised to the power 5, raised to the power 4, or raised to the power 6. We will be restricted up to powers 3. So here, if at all it is asking for the period of 4, that is this period which is 4, corresponding to 4 as the exponent, this entire value will be given to us. So that puts us at ease. So if we generalize, in general, my amount will look like a P 1 plus R over 100 raised to power n if the number of years is just integers. Here in this case, my amount is going to be P 1 plus R over 2 times 100 raised to the power 2n. So here the difference is 2n, which is important for us. This particular calculation or computation for 2.5 years, so this is for 2 whole years, and this is the remaining period, which is half the year. So that we'll be able to manage. Now let's consider the connections between the amounts of successive years and compound interest of successive years. Here we have taken a very simple example. My principal is 100 rupees, rate is 10% per annum, and time is 3 years. So we want to compute the compound interest for 3 years. So first year, 10% of 100 becomes a simple 10 rupees. So 10 gets added to 100, it becomes 110. 110 is the amount at the end of the first year, which will eventually become the principal for the second year. So my interest for second year will be 110 times 1 times 10 over 100. So this becomes 11 rupees. So which means 110 rupees will grow by 11 rupees in the second year. So eventually it amounts to 121 rupees. When we go to the third year, So 121 rupees has become the principal. Again, it is subjected to 10% rate of growth. So for the third year, my interest is 12 rupees and 10 paise. So my amount at the end of the third year will become 121 plus 12 rupees and 10 paise, which eventually becomes 133.10. So here what we understand is, since our original principal was 100, at the end of 1 year my amount was 110, then it becomes 121 at the end of the second year, and it becomes 133 at the end of the third year. Now if you were to build a connection between them, 110 is nothing but 100 plus 11. How do we get this 11? It is nothing but 10% of 100. 10% of 100 will become 10. So 100 plus 10 becomes 110. 110, and 110, if it is subjected to 10%, it will eventually become 11 rupees. So now we want to generalize. So my amount at the end of the first year is nothing but my P plus the rate of interest applied on the original principal P. In a similar way, amount at the end of the second year, which is A2, is connected with A1, and here we say that A2 is A1 plus rate of interest applied on A1. In a similar case, we build the connect for A3. So this is the connection between the successive years amounts. So in general, if someone had to ask what would be AN, so AN would be generalized as AN minus 1 plus rate of interest applied on AN minus 1. Suppose my n is 10, so it will sound like therefore A10 would become A9 plus rate of interest applied on A9. 9 is 10 minus 1. Similar connections can be established between the compound interest for successive years. So we know that 11 rupees can be written as 10 plus 10% of 10. So which becomes 10 plus 1, which is 11 rupees. So here what we want to say is CI2, compound interest earned in the second year, is nothing but compound interest earned in the first year plus the rate of interest applicable on the CI1, which is CI1 is here. So similar way, CI3 can be written as CI2, compound interest earned in the second year, plus the rate of interest applied on CI2. So this kind of a connection can be established for any successive compound interest, any compound interest earned in the successive years. Now, having understood these two parts, let's consider what is depreciation. Depreciation is decline in the value of the product or the commodity. Certain things are bound to fall in value, certain things appreciate over a period of time. So suppose we buy a car for 10 lakh rupees, and is supposed to undergo a depreciation of 10%. So 10% of 10 lakh rupees would become a 1 lakh rupees. So from 10 lakh you take away 1 lakh, the value of the car has become 9 lakhs. So here in this case, how do we modify the formula? My amount, which was after some period of time, it was P. In case of compound interest where it was growth, this was supposed to be plus, but if it is depreciation, this is minus over a period of n year. So this is my future value would be whatever my current value is subjected to the degrowth, which is 1 minus r over 100. Suppose it is a 10% degrowth. So in that case, how do we modify this? My amount is P 1 minus 10 over 100 the whole power n, which eventually becomes, therefore my amount is P 1 minus 10 over 100 would eventually become 1 minus 0.1, which is 0.9. So we know our multiplier is 0.9 raised to the power n. So here we understand that this P will naturally become smaller value in n number of years. So my future value is always going to be smaller than the current value. So future value is current value 1 minus r over 100 raised to power n. In a similar way, if we consider the rate of depreciation as 10%, and let's consider our original value was let's consider as 100. So 100 is going to undergo a fall in value by 10%, so which means my multiplier is 0.9 raised to power 1. So my future value would become would become 90 rupees 90 units. Similarly, if we go to the next, here my future value would become my current value, which is 90 times 0.9 raised to the power 1 again. So now my future value is going to become 81. 9 is 81. Let's consider this to be rupees only. Even this is rupees. So here we have understood that there is a decline in the value. If we continue this particular process and we go on, it will take infinite years for the value to eventually reach 0. It is still not 0, but it is tending towards 0. So in this case, the value never becomes 0. Now what we realize is the depreciation for the first year was 10 rupees, which you want to call it as TP1. The depreciation for the second year, which you want to call it as TP2, is 9 rupees. So if we were to look at this particular connection, dp2 is dp1 minus r% of dp1, it will stand correct for us. Let's see how. Therefore my dp2, which is 9, is nothing but 10 minus 10% of 10. So if I just look at the right hand side part, which eventually becomes 10 minus 1, which is going to become 9, which is this particular value of ours. So yes, this particular formula also works great for us. Now how can we establish connections between the amounts of two non-successive years? Suppose we are given A3 amount at the end of 3 years and an amount at the end of 5 years. So here I can say my future value, that is amount at the end of 5 years, is my current value, it is amount at the end of the third year. It is subject to growth at the rate of r% per annum, and here the period is 2 years because the gap between these 2 years is just 2. So this is how we can use different formulas for different scenarios. Next we will meet up with the problems based on these scenarios. Thank you so much.